Welcome back to The Explainer. So, if you're working with plastics, whether you're a fabricator, a sign maker, or an industrial designer, you already know the drill. Not all materials are created equal. Today we're diving into a really fascinating article called HHC Acrylic, inside the Taiwanese factory that makes your sheet. We're basically going to use this piece to bypass those glossy distributor catalogs, pull out the actual hard data, and uncover the factory secrets you need to, stop guessing and start building with absolute precision. Let's get right into it.
Okay, so let's kick this off with a pretty simple question. Have you ever peeled back the protective masking on a fresh sheet of colored cast acrylic and noticed the tiny little gold stamp? It usually has a hexagon, 3 letters, and a number. I mean, honestly, most of us just rip the masking off and toss it without a second thought. But as the article points out, that specific mark actually unlocks exactly where your material comes from. And understanding it, well, it can completely change how you order your stock.
Section 1. The origin story. Hsin Hwa Chemical, or HHC. The article explains that this little hexagon belongs to HHC, a factory based in Taiwan that has been mastering a very, very specific art. Since the spring of 1973, they've been pouring liquid acrylic monomer between massive sheets of glass. It's a pretty incredible supply chain journey for a product they literally call beauty glass. It starts its life in a rural manufacturing plant in Pingtung. From there, it makes about an hour-long trip north to the massive port of Kaohsiung for global export, sailing across the globe until it eventually lands right on the racks of your local North American warehouse, completely ready for your shop floor.
Section 2. Decoding the Factory Codes. Beyond Marketing Names.
Now, the article moves us way beyond those fluffy marketing names you always see in standard catalogs. And the author makes a really fantastic point here. Relying on generic color names like royal blue or cherry red is honestly a recipe for disaster in professional fabrication. Think about it. Royal blue means absolutely nothing if you suddenly have to switch suppliers. But when you order a factory code like Blue 2051, you are asking for a specific mathematical formulation. It is a precise recipe. That means you are absolutely guaranteed a perfect color match even if you're ordering a second batch, say 18 months later from massive retail rollout. You're not just crossing your fingers and hoping it looks similar under the warehouse lighting, you are getting the exact same chemistry.
Going beyond just standard colors, the piece also highlights these highly specialized formulations known as day and night codes, like C01M. This is wild. These are engineered to read as a sleek, solid color, let's say a deep black during the day, but then they completely transform into a bright, glowing color when backlit by LEDs at night. Savvy sign shops are out there specifically asking for these codes by name because it allows them to create this really dynamic, dual identity signage without having to build a super complex, wildly expensive second face.
Section 3. The Reality of Sheet Tolerance. The Joinery Trap.
All right, so here the article dives into the physical reality of the material itself. Fact, cast acrylic is never perfectly flat. It's just a physical reality, but it's one that can completely ruin a project if you aren't ready for it. Because it's cured in uncalibrated glass molds, instead of being squeezed through perfectly calibrated metal rollers, the thickness is always going to vary. Now, every honest factory out there publishes a tolerance table to account for this. And if you look closely, the shape of the numbers on this table actually reveals a hidden mathematical rule that you can use on the fly.
In that secret, it's the 8% rule. If you look at the published data in the article, from a 2.8mm sheet all the way up to a 15mm sheet, the allowed variation is exactly 8% of the nominal gauge. Not approximately, but exactly. So you literally just multiply your gauge by 0.08, and boom, you instantly know your exact tolerance margin. It's incredibly satisfying when the math lines up perfectly like that, right? But, as the article shows, this builds into a major real-world issue known as the lamination math problem. This arithmetic gets really uncomfortable when you start stacking or joining parts. Think about it. If you have a single 5mm sheet that actually arrives at, say, 4.65mm, it's still going to drop perfectly through a routed slot. No big deal. But if you laminate 4 of those together to create a 20mm block, that 8% tolerance compounds. Your actual block thickness could end up ranging anywhere from 18.4mm to a very tight 21.6mm. So if you pre-machined a captive frame to exactly 20mm, yeah, it simply is not going to fit.
Section 4. The Heavyweight Standard. The 4x8 Reality.
Now, looking at overall sheet sizing, the data reveals a pretty surprising structural limitation in global acrylic manufacturing, and it directly dictates how you have to buy thick materials. So while HHC casts 18 different sheet formats for the thinner gauges, almost all of their wider formats, like your 60 by 96 or 72 by 118 inch sheets, they completely max out at just 25 millimeters thick. But take a look at the globally standard 48 by 96 inch sheet, your typical 4 by 8 format. That specific size keeps going all the way up to a massive 75 millimeter block, meaning if you're nesting a really thick part, it is almost certainly coming out of a 4 by 8 sheet, literally wherever you are in the world.
Section 5. Proof in the testing, beyond distributor claims.
The author really stresses this next point. A distributor's verbal promise that a material is, quote, good enough is essentially worthless on an industrial level. Real confidence? That only comes from published laboratory reports. And HHC, they don't hide their data. The article actually links to 8 rigorous documents right on their site. So whether you need an SGS FDA food contact test for, like, a bakery guard, or you need proof of weather resistance for a sign that's going to face freezing winters, the hard data is right there to back it up.
Out of all those documents reviewed in the piece, the light transmission curve is definitely the most fascinating. It brilliantly illustrates how cast acrylic allows roughly 90% of visible light to pass straight through, which keeps it incredibly clear. But then, as the data shows, it literally drops off a cliff right around 350 nanometers to aggressively block out destructive ultraviolet light. And that right there is exactly why high-end museums use this stuff as the default material for display cases. It lets you perfectly see the art while completely protecting it at the same time.
Section 6. Why Cell Cast Wins. Cast versus extruded PMMA.
As the article brings its analysis to a close, it tackles the ultimate shop floor decision you have to make: slow batch cell casting versus mass-produced extruded sheets. Cell casting actually cures each sheet in its own individual glass cell. Now, does it cost more? Absolutely. But it delivers this gorgeous flame-polished edge right off the laser, striking bright white engravings and significantly higher heat deflection. On the flip side, extruded PMA is continuously pushed out. It's definitely the rational, cheaper choice, but honestly only for high-volume flat cuts where those edges are going to be completely hidden inside a frame. So, armed with all these factory secrets uncovered in the article, from the 8% rule to the structural limits of sheet sizes and the real chemistry behind those factory codes, the final question you really have to ask yourself is this: are you going to keep blindly trusting the number printed on the invoice, or will you actually measure your sheet's true gauge before you make your next expensive cut? Thanks so much for joining me on this explainer. Until next time, keep measuring and keep building.